Morning students, hope all of you are doing well. Last class we discussed the chapter 1 operating system user interface. So we covered the topics of what is operating system, what is the need of operating system, what are the different types of interfaces, that is character user interface, command user interface or graphical user interfaces, and what are the different features and functions of operating system, and what are the different types of operating system. And few assignment questions are given, most of you are done. Now I am going to the new chapter. I'll give one more assignment on operating system, fill in the blanks or MCQ form. So, but soon I'll upload the assignment in the Google Classroom. Now I'm going to the chapter 2, number system. Number system is it is something related to your mathematics only. Okay, that only will cover. So what computer understand that we'll discuss. Okay, it covers the basics of number system and introduces the types of number system, that is decimal, binary, octal and hexadecimal number systems, and few conversions, that is binary to decimal and decimal to binary, that two conversions we'll see. Okay, these conversions are mainly this chapter is a very crucial chapter. We will get 1 mark from this chapter from NDA UPSC NDA exam. You will get definitely one question, that is conversion, that is from decimal to binary or binary to decimal. This is a very important chapter. So how the computer understands language, whatever we given that numbers in the form of ones and zeros, that deals with this chapter. Yeah. So now let's go to this chapter briefly. How this number system will work with us. Okay. How the number system will work. Yeah. Understanding number system. So the number system. The name itself contains the system of numbers. That is, it is the way to represent the numbers. It is the way to represent the numbers. So how the earlier we used to represent the numbers by using the finger counting, that 1, 2, 3, 4, 5, 6, 7, 8. In the fingering process we used. That is the earlier version that we say as a decimal number system that basically every human knows after the introduction of the zero by Aryabhatta, Indian scientist. So we formed, the computer will have three more number systems, that is binary, octal and hexadecimal. Now we'll discuss that what are all the types of four systems, and also what is the role of that decimal, binary, octal and hexadecimal in the computers, in the aspect of computers. So I am discussing about decimals. The decimals, the name itself contains decimals, means it contains the 10 numbers starting from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 represents the uh, decimal number system concept, whereas 0 to 9, that is decimal number system, it contains up to 10 symbols. That's why it is called as decimal number system. And the second one is binary number system. It is used by the computer. It contains the only two numbers, two symbols, that is 0 or 1. And it is octal number system, which contains 8 symbols, that is 0 to 9. Okay, 0 to 9, that is 0, 1, 2, 3, 4, 5, 6, 7. Sorry, 0 to 7, that is 0, 1, 2, 3, 4, 5, 6, 7. So the 7 symbols it contains. Okay. Next, hexadecimal, that is it contains 16 symbols. So 0 to 15. So up to 0 to 9, we'll say it as one number. From 10 onwards, we write 10 as a, B as 11. So on like that, it will continue up to 15. These are the four basic number system we are having. Okay. What is the use of this number system that we discuss in this chapter? Yeah, being a machine or electronic device, the computer understands in the form of electronic device. It works with the voltage, so it accepts in the results in the form of zeros and ones. Zero means on state, one means off state. If I say a digital signal has only two states represented by two voltage level, that is on and off, or high and low. I can say high means one, low means zero. Understand? Computers accept input and deliver output in the form of digital signals. That you know everyone. So computer तो binary language में accept करता है, digital form में accept करता है. So it deals with the numbers only two symbols, that is zeros and ones, where zero stands for off state and one stands for on state, or high or low. So for a computer to process numbers, it is important to be able to represent numbers as a digital signals. Yes. So when we are giving instructions or while we are understanding, every time we cannot deal with the digital signals, that is zeros and ones. We the humans will understand the decimal number systems. So they are represented from 0 to 9. The numbers formed with the help of that 0 to 9, that numbers will understood. Yes or no? So to achieve this, you need a number system that uses only two symbols to represent any number. So जो कंप्यूटर को जो चाहिए डिजिटल सिग्नल फॉर्म में, उसके लिए तो बाइनरी सिग्नल ही चाहिए, बाइनरी नंबर फॉर्म में चाहिए, वो तो ओनली टू सिंबल्स दैट इज हैविंग, दैट इज 0 and 1. So we need this concept called as a binary number system. Usually only two symbols, the bi means 2, so two symbols, the deci means 10, so that's why 10 numbers 0 to 9, bi means 2, that's why it is having two symbols, that is 0 and 1, to represent any number, and therefore provides a direct way to representing numbers in computers. Two other number systems, octal and hexadecimal, help represent the binary system concisely, making it convenient to deal with the large strings of zeros and ones. So ये जो octal and hexadecimal जो है, so what will help in representing बाइनरी नंबर्स को थोड़ा सा कन्वीनियंट में डील करने के लिए, लार्ज नंबर ऑफ जीरोस एंड वंस को जब डील कर रहे हैं तब ऑक्टल एंड हेक्साडेसिमल काम करते हैं. कैसे काम करते हैं हम लोग कन्वर्जन्स में देख सकते हैं. ठीक है. So number system is known by its radix or base. So how we can find that this number is decimal system, or this number is binary system, or this number is octal, or this number is hexadecimal, with the help of its representation known as a radix or base. What is with the help of its representation known as radix or base? What is number system? The way to represent the numbers. So इसमें ह्यूमन को जो बहुत सारा माने ह्यूमन नॉन नंबर सिस्टम इज डेसिमल सिस्टम. द कंप्यूटर विल अंडरस्टैंड थ्री मोर नंबर सिस्टम, दैट इज binary, octal, hexadecimal. So binary system where it contains only two symbols, that is 0 and 1, where 0 stands for off state, 1 stands for on state, where 0 means low, 1 means high, that everyone know. The decimal number system uses 10 symbols. So how to represent that particular number system? With the help of how will you identify this number is belongs to this number system? With the help of its concept called as a radix or base. The decimal number system uses 10 symbols and therefore has a radix or base of 10. So decimal number system में कितना numbers है? 10 numbers है. That's why इसका जो base और radix जो है 10 करके लिखा हुआ. So based on that we'll identify that this number belongs to this decimal number system. So now see, the radix of number is usually written as subscript. Yes, subscript and superscript, you know, in the Word document we see in subscript, and HTML also we see in subscript tag and superscript cap. So subscript का कैसे लिखते हैं तो H2O CH3COOH वो जो कैसे लिखते हैं, that is subscript we say. The radix of a number is usually written as a subscript with that number, where the number is written within parentheses as shown in the following examples. Now you see 368 base 10. So with this representation we can identify that 368 belongs to which number system? Decimal number system. Next, second one is 10101 base 2. So as it contains base 2, we can tell that this number system belongs to the decimal number. This number belongs to binary number, where it contains 1010 zeros and ones. Even though if it contains only zeros or only ones with base 2 or radix 2 we say, so then we can say this number system belongs to the binary number system. Understood? So how we'll identify the particular number system? With the help of the concept called base or radix. So the radix or base contains based on the number of symbols which that particular number system uses. In the case of decimal number system, the base will be 10 because as it contains the 10 symbols, that is 0 to 9. In the case of binary number system, the base will be 2 because as it contains only two symbols, that is 0 and 1. In the case of octal number system, it is the base is 8 because it contains the 8 symbol, that is 0 to 7. In the case of hexadecimal number system, we are having the base as a 16 because it contains the 16 symbols, that is 0 to 15, or we can say as a 0 to F because from 0 to 9, after that from 10 onwards we'll say as a B C D F. Okay, clear? So based on the base or radix or system, we'll identify that this number belongs to particular number system. Clear? I think from these examples you are identifying that this 368 belongs to which number? This is a decimal number. So 10101 base 2 belongs to which number? It is what? Binary number. Okay, clear? Next, we will discuss something about decimal number system. How the decimal number system is. The decimal number system uses 10 symbols and therefore has a radix or base 10. So that only I told, based on the number of symbols which the particular number system supporting. So the base or radix are given as a 10. The symbols are generally from 0 to 9, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the numbers which are formed from that particular symbols, they are all belongs to the decimal numbers only. Every digit in decimal number system is identified from its position, that is from right to left. So जो right से left तो identify करके उसको हिसाब से हम लोग ये डेसिमल नंबर सिस्टम को आइडेंटिफाई करते हैं. सो एक ये जो टेबल दिया देखो, नंबर 345, सो 345 is one number, इसका पोजिशनिंग वैल्यू देखो, units place, tens place and hundreds place. Units place is denoted with the a power 0, that is 10 power 0, as it contains the 10 symbols, so 10 power 1 and 10 square. Okay, clear. Positioning value 10 square, it is hundreds place, it is tens place and it is units place. That is now 3 into 10 square, 4 into 10 to the power 1 plus 5 into 10 to the power 0. Then we'll get the value of the 345, that is 3 into 100 plus 4 into 10 plus 5 into 5 into 10 power 0, that is a power 0, anything value will be 1. Now if you multiply that number with the positioning value, that is 3 into 10 square or 4 into 10 to the power 1 plus 5 into 10 power 0, we will get the value of the particular number. The leftmost digit will be the most significant digit or rightmost digit will be the least significant digit. जो left में जो है that is 3 will be the most significant digit and the least significant digit will be rightmost, that is 5. Clear? 345. Clear. Next, binary concept. Okay, the binary number system uses mainly two symbols, that is zeros and ones. The by stands for 2, that is it contains only two values, that is two symbols, that is 0 or 1. So we say it as a bit, binary digit, so or binary number. So by or digit say we got that number, we got that word called as a bit or a bit, that is 0 or 1, also known as bits or binary digit. Okay, clear. Every bit in a binary number system is identified from its position, that is from right to left, in the as how it is used in the same case, that is in the case of decimal number system. Here also same concept, it is identified from its position, that is from right to left. So for example, the given 110, so this we cannot read like a 110. Okay, this will be read as a 110 only. Clear, all of you? This cannot be read like a 110. So the binary number will be read in the form of 110 only. Okay. So now the binary number example they given as a 110. So every bit, that is first bit from the from that is right side is 1, and again after that is followed by 1, again followed by 0. So from right is again the positioning value will be 2. In the case of the decimal, that is units, tens, hundreds. In here also the base will be 2. In the case of the decimal, that base will be 2, base will be 10. Okay, 2 square, 2 power 1, 2 power 0. Clear. Now how will we get that number? That 1 into 2 square plus 1 into 2 power 1 plus 0 into 2 power 0. Clear. In the case of decimal number, we used the units, tens, 100, that is 10 square, 10 to the power 1 or 10 power 0. Now in the case of binary number system, as it contains only two symbols, that is two symbols, that is 0 and 1, we are using the from the right to left, that is 2 square, 2 power 1 or 2 power 0. Now multiply that particular each number from the left side or right side onwards with the positioning value, that is 1 into 2 square, that is 4, plus again 1 into 2 power 1 plus that is 2, 0 into anything, that is 0. So 4 plus 2, 6. So now I can write this binary number 110 stands for 6 in the case of the decimal number system. Now you are getting the value that is from the decimal value from the binary value. So binary का positioning value से हम लोग को decimal number आ रहा है, देख रहे हैं? 1 into 2 square plus 1 into 2 power 1 plus 0 into 2 power 0 will give the decimal equivalent to 6. Okay, 110 base 2 equal to 6 in base 10, that is in the decimal form. The leftmost digit will be the most significant bit and the rightmost will be the least significant bit. Okay, clear. Next one, octal number system. Octal number system, the octal number system uses 8 symbols. Octal stands for 8 symbols, that we see. Octal number system uses 8 symbols, therefore it has the radix or base of 8. Yes, 0 to 7, 0 to 7. Every bit in the hexal number, every bit in the octal number is identified from its position, that is from right to left, as in the case of the in the case of binary and also in the decimal. That is, for example, 140, say again it is 140, we will read as a 140, that is its positioning value जो है 140, units, tens, hundreds place same place, that is positioning value from the right side. So 8 square, 8 power 1, 880. So जितना भी अगर मान लो इससे पहले एक और डिजिट है, again 1 is there, then 8 cube 8 square, 8 power 1, 8 power 0, like that you will get. Clear? That is again multiply each number with the particular positioning value, that is 1 into 8 square, that is 4 into 8 power 1, or 0 into 8 power 0. It means that 1 into 8 square plus 4 into 8 power 1 plus 0 into 8 power 0 will give the decimal equivalent, that is 1 into 8 square kitna 64 plus 4 into 8 plus 0 into 1, that it will give the 96 in the, which is equivalent to the decimal number in the case of 140 octal number. Clear? So it means that is, if you multiply the value from the right side to left side with its positioning value, then we'll get the decimal equivalent of that particular octal number. Clear? 140. Next, this hexadecimal number system. Hexadecimal numbers, hexa means 6, decimal means 10, so 6 plus 10, that is 16. So it contains 16 symbols, therefore it has the radix or base of 16, that is from 0 to 15. So as we cannot write that number from 10, so 10 को हम लोग A करके लिखते हैं, 11 को B, 12 को C, ऐसा करके हम लोग लिखते हैं. ठीक है? Up to 15, that is 15 will be written as a F. Okay. 10 is represented as A and so on. Okay, that's what I told. Every bit in hexadecimal is identified from its position, that is from again right to left only. For example, A to B, A to B. A is means 16. Sorry, 10. 2 means normal number. B means 11. Okay, so that is also from positioning value. Same in the case of how we are writing the positioning value in the case of octal or decimal, or in the case of binary, how we written the same case it also applicable in the hexadecimal also. That is positioning value from right to left, that is 16 square, 16 power 1, 16 power 0, what you are seeing in the slide. See, A into 16 square plus 2 into 16 power 1 plus B into 16 power 0. What A stands for? A stands for 10. 10 into 16 square, that is 10 into 16 square, that is 10 into 256 plus 2 into 16 plus B means 11 into 1, 16 power 0. So this is equivalent of decimal number of the particular hexadecimal number of the A to B. Clear? A to B. Next, conversion of decimal to binary. Conversion of decimal to binary and binary to decimal. This is very important. If you complete this one, we'll complete this chapter. But this is very crucial chapter. We have to do some exercise on this decimal to binary and binary to decimal, because this conversion, from this conversion only will get the 1 mark bit, compulsory 1 mark bit from the UPSC NDA. Clear? Okay. Conversion. So till now we discussed the 4 number system. The number system is concept of representing the numbers. The earlier number system which we are following by the humans is the decimal number system, but the computer will understand the 3 more number system, that is binary, octal and hexadecimal. We say that binary, the binary decimal में तो 10 सिंबल्स रहता है. बाइनरी कैसे आइडेंटिफाई करते हैं ये 4 नंबर सिस्टम को? उसका बेस और रेडिक्स के हिसाब से. सब बेस अगर 10 होने से डेसिमल कहता है, अगर बेस अगर 2 होने से उसको बाइनरी कहता है, अगर बेस अगर 8 होने से उसको ऑक्टल कहता है, अगर बेस 16 होने से उसको कहते हैं hexadecimal. Now how will we convert the decimal to binary or binary to decimal? So this concept is very important. You see, once once you go to the textbook also you'll get. Okay, algorithm also they given clearly how the process steps you have to see clearly. Okay, how the decimal number is converted to binary you've seen. So in the previous examples, when I'm discussing the concept of decimal, binary, or concept of octal or hexadecimal, you've seen that each and every particular number system is converted into decimal. So now I can say that how the decimal is converted into binary. Can I say? So each and every number system whatever we see, that is decimal or binary or octal or hexadecimal, whatever we see, the ultimate every system is converted from particular number system to decimal only. So how the decimal will be converted to binary? Clear? How the decimal number will be converted to binary, that you see. At times you need to convert a number from one number system to another system. Distinct methods have been defined for conversion between each pair of number system. You can convert a decimal number to its binary form by using a method of successive division by 2, the radix of the binary number system. कैसे successive division करते हैं हम दिखाते हैं. Successive division, everyone knows successive division. Okay, like it's a form of LCM, leaving the remainder. Okay, successive division which you are getting from the class 7, 8, whatever you see in the mathematics, also successive division you seen. Okay, successive division by or LCM, with the concept of small LCM with leaving the remainder, the radix of the binary number system. So decimal क्या है? Representation 10. The binary contains only 2 symbols. So to convert the decimal number to binary, I have to do that particular decimal number, do the successive division with the help of 2, because as the binary contains the radix of 2. Now put the remainder to the right of quotient and repeat this process till the quotient becomes 0 or 1. पुट द रिमाइंडर मतलब 2 से डिवाइड कर दिया वो डेसिमल नंबर को, जो रिमाइंडर आया वो राइट कॉर्नर में क्वेश्चन में रख के ये जो प्रोसेस को जब जब लास्ट तक 0 और 1 आने तक वो करते रहना है. और राइट डाउन द रिमाइंडर्स इन रिवर्स ऑर्डर फ्रॉम द नीचे से जो लिखेगा तो वो दैट इज इक्वल टू बाइनरी नंबर. सो सी दिस एग्जांपल, तो डेसिमल टू बाइनरी नंबर 45 जो दिया है उसको बाइनरी में कन्वर्ट करना है. 45 डेसिमल करके कैसे पता चल रहा है, इसका बेस जो है 10 है एंड बाइनरी को हम लोग कन्वर्ट करना क्योंकि हाउ इट विल रिप्रेजेंट, उसका बेस जो है 2 करके दिया है. नाउ हम लोग क्या करना, क्या फर्स्ट स्टेप क्या है, distinct method you can convert the decimal number into decimal by using the method of successive division by 2. Okay, and put the remainder to the right of the quotient and repeat this process until the 0 or 1. Now see, now 45 को देखो, 45 को 2 से डिवाइड किया है, रिमाइंडर what will how many times it will divide, 22 times it will divide, that is 44 and leaves the remainder 1. so remainder को लेफ्ट साइड में रखो. again 22 को 2 को 2 से फिर डिवाइड करो, सक्सेसिव डिवीजन that is 11 times it divides and leaves the remainder how much, 0. is okay, leave keep it remain. कब तक करना है ये, लास्ट में 0 और 1 आने तक करना है. ठीक है. now 2 divides 11 how many times, 5 times and leaves the remainder 1. okay, clear, देख रहे. now again 2 divides 5 2 times, leaves the remainder 1. again 2 divides 2 2 divides 2 1 time and leaves the remainder. I can stop here also, so you can we can stop here, that is the number will be 1 0 1 1 0 1. so the way it is represented, see 1 1 0, or you can, so 2 divides 1 0 remains, that's why you can start from 1, that is 1 1 here 1 0 1 1 0 1, that is लीस्ट सिग्निफिकेंट बिट जो है दैट इज 1 आना चाहिए, मोस्ट सिग्निफिकेंट बिट जो है वो 1 आना चाहिए. देख रहे, लीस्ट सिग्निफिकेंट बिट विल बी 1, मोस्ट सिग्निफिकेंट विल बी 1. क्लियर. अगेन अगेन इन जस्ट मिनट 79 को 2 को कैसे करेगा देखो. 79 डिवाइड्स फर्स्ट 2 30 को बेस को कैसे करते हैं बाइनरी नंबर, जस्ट यू टेल मी. ओके, with this I'll conclude this you to take the example and do the exercise. After that I'll tell the example how to convert the binary to decimal, and also I'll give some exercise on the conversion from the decimal to binary and binary to decimal. Okay, with this chapter will be a very simple chapter, we'll complete this chapter. Okay, decimal to binary and binary to decimal. Okay, and few exercise questions are there, I'll discuss all the things. Okay, we discussed in this unit the number system. We have four different types of number system, that is what are the decimal number system, binary number system, octal number system and hexadecimal number system. So decimal number system is the earliest method which we used, where it contains the 10 symbols, that is 0 to 9. It is represented with the help of the base 10. Then we see the second number system, that is binary number system, which computer understand, that is 0 or 1, where 0 stands for or off states, 1 stands for on state, that is high or low. Okay, then it is represented with the base 2. Then the third number system, that is hexadecimal number octal number system, where it contains the 8 numbers here, 8 symbols, that we say 0 to 7. so it is represented with the base 8. okay, next hexadecimal number system, it contains the 16 symbols, we denoted from 0 to 15 or 0 to f we say. okay, where 0 to 9, after that from 10 onwards it is represented as a b c d e f, so on like that. okay, next it is represented with the base 16 as it contains the 16 symbols. okay, clear. now how will we convert this decimal to binary, that we seen, that is उसको 2 से सक्सेसिव डिवाइड करके जो क्वेश्चन जो रिमाइंडर आया उसको साइड में रख के जो नीचे से ऊपर तक वो करना है, दैट इज मोस्ट सिग्निफिकेंट से तो लीस्ट सिग्निफिकेंट डिजिट होता है. क्लियर ऑल ऑफ यू. So now you do these two exercises, and also next class I will discuss about how to convert the binary number to the decimal number. We'll discuss. Clear all of you? Clear? Okay. In between time, you can go for the back side of the textbook. You can do all the conversions of the decimal to binary. Still, if you not understand, again I'll go through this video. So decimal to binary. See this one. This 45 जो नंबर है, पहले 2 से डिवाइड किया, जो दो से डिवाइड करने के बाद 22 के साथ 22 टाइम होगा, उसका रिमाइंडर 1 होगा. देन अगेन 22 को 2 से 11 टाइम डिवाइड हो रहा है, रिमाइंडर कितना हो रहा है, 0 हो रहा है. अगेन 11 को 2 से डिवाइड हो रहा है, उसका 5 टाइम्स इट डिवाइडिंग एंड लीव्स द रिमाइंडर कितना है, 1. अगेन 5 इट इज डिवाइडिंग बाय 2 and leaves the remainder 1. Again 2 divides 1 and leaves the remainder 0. Now you can stop here as per the algorithm. You see put the reminder to the rate of the quotient and repeat this post process until the quotient becomes 0 or 1. Okay, मैं 1 तक आने तक कर दिया, that is 0, 2 divides 1 0 and the remainder कितना है 1 है. So इधर तक कर दिया, 0 तक कर दिया. That is now it is the least significant, it is the most significant digit and it is a least significant bit, that is 101101. It is a binary equivalent to the decimal number 45. It is a binary equivalent to the decimal number 45. Clear all of you? Clear? So now 79 base 10 को decimal को binary को convert करना है, 30 base 10 decimal को binary में convert करना है, and text book में 4-5 एक्सेस दिया है, उसको भी convert करना है. Clear all of you? Clear? Hope all of you understood. If you still not understood, go back through this video and you can give the comments, so I'll reply to your questions. Okay, stay safe, stay home, stay prepared. Signing off. Thank you.